So we want to incorporate the memory macro cells as opposed to lookup tables to implement memory. So in this video, I'm going to show you a couple of methods to do this. So as it turns out, there are 3 ways to do it. So one is by HDL instantiation. So let's see, what does that mean? Okay, we're going to do this in here, and we're going to do the HDL instantiation. Okay, so we go to tools, and then from there, we're going to do language templates. And from the language templates, we're not going to go to the system Verilog, we're going to go to the Verilog. So in Verilog, you're going to see a few things. We're going to do the common constructs, and within it, we're going to do, or maybe device macro instantiation is better. Okay, not the common construct is defined. Well, we're doing macro, one of the macro cells. What we have is we're working with the Arctic 7. We're going to go to RAM, and here we're gonna have a bunch of things. So what we're going to be doing is we're going to, let's say, start with the let's say true dual port RAM, for example. Let's assume that you want to do one of those in here. Okay, so what happens, it actually gives you all of this here. So what you can do is you can just copy all of them and open a new file and just paste that, and that way you'll force it to actually use a certain VRAM. Of course, if you copy it, and let's open a new file just to see how it looks like. So for example, we're going to do sources. Let's just basically paste it at the very end just so that we get to look at it. So you're going to see that it's basically instantiating something. It's not very easy to see, but this is what's instantiating. It's VRAM, TD, blah, blah, blah. And you can see it has certain parameters in here. You're going to have to specify how many kilobytes, what type of series, and you're going to have to understand what do these mean. We will not do this, and the reason why is because this is kind of difficult. You're going to have to go through the Xilinx implementation, figure out what do they mean by each one of these parameters, each one of these inputs, and actually modify it accordingly. And as you can see, it's not as simple as it looks. Okay, so what other ways are there to implement that? Well, the other way is actually to go to the IP catalog, which is basically by block memory generator or distributed memory generator. That's the second one that you can see in here. Okay, so let's get to see it, and we're going to go to IP catalog, and then from the IP catalog, actually, we're going to do memory. Okay, and in memory, you're going to see a bunch of things. We're not going to go to the AXE. We're going to go to the memory element. You have block memory generator, distributed memory generator. We're not going to do the distributed memory generator. This is the one specific to Xilinx, the one that uses lookup tables. So we're going to do block memory generator. So you double click on it, and you'll get a wizard, and that wizard will guide you through the different things that you can actually set up that RAM to be, and it will generate the instantiation that you just saw, but it will be set up accordingly. So for example, let's say how many ports you want, whether you want it 16-bit, write depth and whatnot. You can actually go through all of them in here and just specify it, and it will generate that instantiation code for you. We will not also do that. What we're going to be doing is go through the last option, which is basically by a behavioral HDL inference. We're going to write HDL in Verilog code to describe the behavior of what we want, but we're going to be following a very specific template. And if you follow that template, Vivado will interpret it as your intention to use VRAM.